For my third of three videos on my Apache Spark overview. Again, like the other two, there's me, and like the other two, there was that agenda. I'm working on that bottom big bullet below the waterline. Feel free to, if you're finding this video, look in the notes, find the bigger section. I'll try to put them all in a little playlist together to make sure they all fit together. You can find them easier. Below the waterline. So below the waterline, the same stuff we've been talking about at the surface come to bear, but some of the stuff we need to kind of look at and talk about a little bit harder. We talked about that data sets, data frames, RDD, data sets, whatever, are distributed. They're broken into partitions. Those partitions can be run on different machines, do the same kind of processing, create that parallel processing that's super important and critical, makes the world go faster, better. So talked about that, kind of review. And we talked about lazy execution. We talked about transformations don't really do work yet. They just build lineage. We talked about actions or some kind of input-output operation and force work to happen. But there's another way to look at all those same methods, another set of kind of optics to glare at them. And I would say we can call methods either narrow or wide. And narrow operations are things that we really can do in a very parallelized fashion, a mutually exclusive kind of operations, standardizing upcasing something, filtering something where it means if I'm working on partition 1 and someone else is working on 2, 3, and 4, it doesn't matter what they do or what I do. We're going to get to the same result. We're just working on our own slice. Now, those other ones, and this would be more like concepts like group buys and orders and things like that, that require to say, you know what, the data set probably needs to be reswizzled, or technically a term is called shuffled or reshuffled, rebuilt. Still probably going to use partitions, but I mean to move data around and realign where things fit, what data lives in which of the partitions. And this is, as it says there, that's going to be kind of expensive. So let's try to, I'll pick on some of those earlier. I'm going to use the RDD API that we said back in the second video, that we are not trying to master it, but worth one to kind of look at. There's some functions on the left. There's some descriptions that I've kind of morphed a little bit from the doc site. But really what I want to say is things like maps. Maps say, look at your data set, loop through it, ultimately do some function on every element in there. So you can do each, if you've got 10 partitions, they're all independently looking at their elements. And what are they doing? They're all building their own 10 independent versions of the new partition and the new data set. That's a transform, and it's a narrow parallelization concept. That's a good thing. Very mutually exclusive. Collect is the one we also saw. Collection was an action. Remember, it triggered work. It didn't really build a data set. But I want to make the point that actions versus transforms and narrow versus wide are mutually exclusive decisions. So there's going to be 4 combinations that can work. That one actually is an action, and it's a wide action because it's saying bring all the information to me, to one person. So actually it forces that data to be reshuffled. It's actually a sequential one. It's an ugly one. But sometimes that's what we got to do. Filter is another one out there. It's transforms. It does a where clause, basically. Absolutely, where clauses can work in a very parallel fashion. The reduce by key is a classic, same thing, much like a SQL group by. So unfortunately, you have to say, whoa, distinct elements that I'm grouping by might be in any and all the partitions. So yeah, I got to reshuffle those so that all the elements for a certain grouped by or reduced by the key all end up in a new partition together, so I can do that operation. So it's a transform, builds another RDD, but it's a wide one. That's an expensive one. I'll show you what that kind of looks like visually here in a second. The last one was another action. Save this thing. Long name. The RDD has these silly names, but the equivalent of if I have a 15 partitioned data set at that moment, and I said persist it to my data lake, it's actually going to write 15 files. It doesn't have to come back and sequentially read them all. They'll just say, hey, I'm part 1, I'm part 2, I'm part 3, all the way to however many partitions they have. So it actually is a very parallelizable activity. It's an action. My main point was narrow and wide are different than transforms and actions. They're all possible. That same code we saw earlier that we didn't necessarily love. Remember, we already separated transformations and actions, but now I'm trying to call out narrow, 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 wide, and then a collection. And I want to show you kind of what that might look like at runtime. So same boxes we saw in the previous video here of RDD 1, 2, 3, and 4, the same kind of logic across the top of what we're doing. Didn't put the exact function call names, but conceptually what's happened. And it's just simply saying that, hey, when I'm reading that file, in the very first column left, RDD1, when I'm pulling that in, I'm looking at a slice of it, a partition 1, and I'm rating it. What else can I do? I can break it apart into words. What else can I do? I can create key value pairs. And I can do all that independent of partition 2, independent of partition 3. Those are, again, narrow operations. I can focus on the narrow piece of code I have, or the narrow piece of data. I can focus on the partition I have and do the work that happens. And we call that pipelining. We're pipelining a bunch of operations. But eventually we want to calculate the totals by word. And unfortunately, partition 1, 2, and 3 over there in RDD3 probably all have the same word. The word the is in all of them. So we have to shuffle it so that all the thes land in a particular partition. We don't care which one, but they need to land together. We need to guarantee they'll get clumped together. This is, for those that remember MapReduce, that's what we're really talking about here. We need to prepare it for reduction. That's what's happening there. And then in my big call out, that's expensive. It takes time to move all that data around all my machines. The bigger the data sets are, the bigger your cluster is. Absolutely, the longer, the more expensive that takes. We want to do as few of these these shuffles as possible. All right, so there we go. Introduced that notion. And you can take that same picture and say, okay, when I went back and saw those pictures you showed me earlier, you talked about these visual tools. Those visual tools of how things ran are going to use terms like partitions, tasks, stages, jobs, that kind of stuff. So I want to kind of make sure that what we just saw, if it made sense, what do we call things? Well, there's that stripped out some of the stuff here now, just focusing on the little bits in the middle. It says partition 1 from RDD 1, 2, and 3. Remember, those were pipelined together. I can work on each element in that independent of all the other elements in other systems. So we call that a task, all the things we can do at once. Read it, process it, look at the next record, and then be doing that, in this case, 3 times. Then we had to shuffle it. We had to build another. And then we really only did one more thing. We did the counts, but if we did the counts and then maybe if we did another filter, for an example, we'd have, something else that could be pipeline. So a task may be one little operation, but it often is more than one, but absolutely can be one. So those are 2 tasks there. But to be honest, if you look, there are 5 tasks. Why do I say there are 5 tasks? Because I went ahead and built all those little black dotted dash lines around those three tasks in the middle on the left side and the 2 tasks on the right side. And I said, hey, guess what? All those tasks that we can pipeline together, and then in number of those, one for every partition, collectively we call that a stage. And these are very similar to what Hive calls them. These are very similar to what Trino calls them. These frameworks fundamentally, conceptually, are doing the same thing. It's that runtime. They have to make some choices about when, where, why, for performance, for resiliency, and so on, so on, and so forth. So plenty of conversations around that I'm more than glad to get into. All right, so what it really kind of says is that, especially past that first stage, if we have a second or third or fourth, any other stage beyond that first one, we actually have to do that shuffling. And as I said earlier, that's the expensive cost in there. So we got we got tasks. All the tasks in parallel are running are called a stage. We have 2 stages here. And then ultimately, it might be 10, 20, 100 of these stages. And this one just has 2. We call all of that together a job. A job is all the stages. And that solves the problem. Often we call it a query as well when we think about Spark SQL, but over the years, Spark SQL got a little more rich, and actually, as a note at the bottom, a query truly actually can do more than one job. It may have to do 2 jobs in parallel that are completely different, and then probably does a union or does a 3rd job that uses those. So it creates a concept called a DAG. I'll talk about all this is a DAG, a directed acyclic graph. all the steps that we need to get something done. And then arguably, if you think what I just said there, if you're familiar with the DAG, if you're not, just think of it as roughly as a big flow chart of activities. Do this, here's a dependency, here's what I'm waiting for, so on and so forth. And then if a query can be more than one job, think of it's a DAG at the DAG level. It's a DAG of DAGs, if that makes any sense. All right. And to see that, it's also called, you can also call it a query plan. You can see it in those visual tools, the monitoring tools. You can definitely see it, a textual version, just say explain on the data set you're thinking about. That'll show you, hey, here's what I'm going to have to do to kind of get there. All right, what else are we going to do? I think we can finish it up on talking about something that most people start with initially, and I purposely waited until now and says, I talked a little bit about the API is important, definitely how those processes are worked in parallel against that API. But at the end of the day, this still has to run somewhere. Still has to run on some big cluster somewhere, big or small cluster. And a couple things that are worth knowing. The nodes or the servers themselves, we usually think of them as, a node. I'm going to say worker there, but the individual processes that do all the hard, heavy lifting are called executors, as you see listed there. Executors, you can have more than one on a machine, whatever. And these actually, as I said at the very beginning, these are when a job is starting, it creates a concept called a driver, and the driver is the brains and smarts. And that driver, either because you told him or figured it out, is going to say, you know what, I need to go get those. I need to get those executors available to me. So they're going to talk to whatever resource manager, Kubernetes or Yarn or Mesos or something, and say, hey, I need these kinds of resources. Generally speaking, if it can't get them, it says, well, I'm not going to play. Why? Because it wants to guarantee, wants to have some repeatability on performance. It doesn't want to, every single time it needs to do another task, it doesn't want to have to go back. So it creates its executors, and that'll be the envelope or the window of processes it can do all the activities in. And then it takes that DAG that it created and takes all those independent little tasks that we talked about and starts assigning them and scheduling them and making sure they run to ground and that good stuff. And ultimately, it gets all finished, all done, all through. And, if it's not a long-lived, like a streaming process or something, or a pretend database or something, if it's just your batch program, when it's all done on through, it'll be aware of it, and it'll tell that resource manager, I'm all done. It'll unwind itself and go away. So think of that executors. Those are the ones that are the real worker processes. Again, think of Trino, think of Hive, and others. They have similar concepts and terms. The names are always slightly different, but they're very similar. Master, worker, architecture is just here we have a persistent, for the duration of a job, persistent solution there. And I think I'll finish it up just a few more thoughts on cluster performance. Again, you can spend all day on each one of these topics, as we learned on there. As I already talked about that top one. We start up, we get our processes that we need, and we keep a hold of them. The Spark program, the driver, keeps a hold of them until we're all done all through, and then releases everything. An important point is those stages in this world here, and in most of the classic true MapReduce engines, they really can't start a new stage until a prior stage has finalized. Why? Because that data matters where it's going to, and it really just can't do that activity. So that's a kind of a statement. Now, that's a yucky one. Top one's a great one. The next one's kind of it is what it is. But Spark also solved differently a problem that all these engines have, which is when it's time to shuffle, how many do I stick with? How many partitions do I stick with? And there are different strategies and thoughts in there, but most of the time you don't know enough, especially of a DAG that has many, many stages. So Spark allows jobs to be run with a feature called AQE, Adaptive Query Execution. And it's simply going to say, hey, I know what I want to do from start to finish, but I think I'm going to stop at the end of the first stage and then recalculate my plan, refigure out an updated vision of what I'm trying to do, and often it gets much better decisions how many partitions that new data set ought to be. Should it be 2? Should it be 2,000? Should it be 200,000? That kind of stuff. And it does make a difference. It's going to make a difference on those really long-running jobs because it probably can do it. It takes time to do this. So it actually makes better choices for the long running jobs that make it better, but it definitely hurts for super fast interactive queries when you're just trying to run to ground and be done with it. So you may choose to turn it off in some situations. I want to make the point that while Spark, you hear all this in memory, you hear caching, all these important things, it's still a classical MapReduce engine that has these stage boundaries, and very likely it's going to spill that data, that intermediate data to disk. In Trino, we would call that the a fault tolerant execution, project tardigrade, that kind of stuff, enabling something like that. And since I mentioned finally, most people start their Apache Spark conversation with the word caching, and I purposely try to avoid it for a variety of reasons. The main thing is the engine does, over the years, got better and better and better, and it definitely does try to be smart and cache things as appropriate, but there's no necessarily a guarantee that spilling absolutely can occur and that kind of stuff. So if you need things explicitly cached, there are functions available that says, hey, this data set, cache it. And I would say that for most ETL-oriented style or transformation type jobs, caching is usually not all that useful, especially on your larger data sets, because you're just looping through them and moving on. Maybe your smaller data sets that you're connecting and looking up and all that make a lot of sense. But there's specific APIs, and those APIs even have persistent options in memory, on disk, combination, all kinds of cool things that make that work. All right, I hope my 3 quick videos here were not too long. I hope they were somewhat useful and interesting, and I absolutely would love to see your comments and questions below, or reach out to me at lestermartin.blog and let me know what you're thinking. Thanks again.